The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello, everybody. I am geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, February 15th, 2024, and we are joined today by our ASL interpreters. We have Rachel and Carrie once again. How are you doing today, Dane?
Doing good, doing good. You know, just a little busy. How are you doing?
Been all right, yeah. Been a fairly quiet week on a volcano. I'm trying to catch up on all of our other activities that we have our hands in lots of things here. But yeah, big earthquake last week caused a lot of chatter. Go ahead.
Yeah, definitely. No, and we're also just dealing with the Hawaii internet and power issues that are all too frequent. But yeah, it's been interesting this past week.
Yeah, if you not aware, we streamed to Facebook on Tuesday from a national park, a cultural event, but power went out at that point in time. So that is in full posted in there as well. But yeah, there has been some challenges with that.
Right.
So yeah, anything you want to add before we get into it here?
No, if anybody has any comments or suggestions or anything like that, go ahead and put them in the chat and we'll try and get to any questions at the end of the stream. But yeah, go ahead and drop them in there. That's it for me.
Sounds great, Dan. Thanks for leading that discussion on the chat. And we'll transition our screen here to get ready for our Hawaiian volcano summary. So our Hawaiian volcano summary for the week. The earthquake rates have gone down on Kilauea. There are still earthquakes occurring at lower levels within that southwest rift zone over the past week. However, the main pulse of that intrusion that occurred about a week and a half ago has passed. That big earthquake that occurred on last Friday, 5.7, is reported to have had no effect on either volcano, Kīlauea and Maunaloa. But when we look a little more closely, we may see that there might have been a slight acceleration of that return to inflation of the volcano at the summit. So after the earthquake shook, the volcano started inflating very slightly, very slowly. And since then, it seems to have resumed its deflation-inflation cycles, which is its normal pattern that it exhibits. So here is a peak of earthquakes around the beginning of the month. And this whole last week has been fairly low values, but still not as low as before the event. Back here. We have the map of earthquakes that shows similar. Most of the events are still here in the southwest rift. And now we have lots of smaller dots compared to last week, showing there's still plenty of activity, but at smaller magnitudes. And this is colored by depth, such that it looks like we lost Rachel there.
Yeah, we'll see if we can get him back.
All right. So with all these small dots, and this is colored by depth, such that the red and yellows are the shallower ones, and the blues and greens are the deeper ones there. So lots of shallow activity, likely magma still injecting into this southwest rift dike zone right through here. And what's been interesting is that further to the southwest over here, we have both these blue earthquakes that mark the deep Pāhala earthquakes. The main 5.7 is just off screen over there, but these other blue ones are part of the aftershock sequence here. But we also have these shallower ones, red ones, that come all the way to the shore and even extend offshore to the southwest here, past this underwater ridge right here. So it seems like activity is still settling down. It's not ceased entirely. And in the meantime, we see signals at the summit. First, let me see if I can get this map to show our 5.7 from last week here. So that's where it was located, almost directly under the town of Pāhala, but 23 miles down, so quite deep near that volcanic root of the island where it's thought the magma has pathways to both Mauna Loa and Kilauea. So looking at the tilt meters near the summit, here we have the story of the past month with the main intrusion event occurring across here. And this signal on the 9th was the big earthquake that shook statewide, was reported felt statewide, and caused several offsets in the instrumentation across the volcano. So here you see this green line as a step down, and it continues after that. But what I was mentioning is that when this earthquake occurs, you see prior to that, the volcano is deflating and deflating, and after the event, it begins slightly inflating and slightly inflating. Since then, that's turned around, and now it's once again deflating and deflating on both axes of this station, which point to Hale-Maumau area and to that upper southwest rift zone connector right through here. So it has begun refilling very slowly, but if you compare that to the massive scale of decrease that occurred here over the actual event, there's still quite a lot of ground to recover, and it's likely going to take its time to do so. To finish off the summary, here's a map of Mauna Loa and very few earthquakes over the last month here on the summit of Mauna Loa. So overall, fairly quiet on both Kilauea and Mauna Loa this past week. Most of the activity has been earthquakes on Kilauea, with a one big event under Pāhala there. And otherwise, we probably have some time to wait until the volcano can resume its previous pressure, given how much energy it expended with this last intrusion. And that's our Hawaiian volcano summary for the week. So good to see we have Carrie back. I'll try to add a little extra summary there at the end. And now we can move on to our observations. All right, so let's see here. Start off with this is last 24 hours from the west edge of Kilauea caldera up at the summit. This is showing through the night, and you might note it's pitch black. There is no glow at all until the sunrise comes up here. So the fumes coming out, you see the accumulation of minerals on the surface, weather comes in, but otherwise it's very dark and very quiet on the surface here of Kilauea. That's the summit. We can look at the same pattern here on a upper southwest rift. This is a MITD camera. Once again, showing pitch black at night. Nothing to see, very quiet and dark and quiet. And here in the daytime, nice clear skies, start of the day, and view across the lava flows of the desert. So that's it for our visuals today. There is not much else to see that's different to spend your time on the surface here today. So we'll switch over to a little bit more in-depth discussion of our earthquakes, as that's been the story this past month, really, on a volcano. Even longer, back to October, really, right? So to start off, here is our 5.7. We might as well start with that, since that was the biggest chatter. And plotted on here are all 378 aftershocks thus far in a sequence, according to the USGS map. So there is a big one, 5.7, 23 miles or 37 kilometers down, and you can see that all the other ones are in that range as well. So highlighted by a 3.5 that came within 6 minutes afterwards, and then a 3.4 that came another 25 minutes after that, another 3.4 that was 3 days later, and then you can see on further 2 3.3s, 2 3.1s, 3 3.0s, and lots more are going down from there. And so lots of events, all under Pāhala. You can't even see the word of the town, Pāhala, right underneath there. And that's where these are occurring. So diving in a little bit more, these are the felt reports submitted onto the website of the national park. You see this says 5,286 responses. And that's a huge amount of responses. And if you look, they're actually all the way off the map here to Kauai, right? And you can see that they're colored by the intensity reported by the citizen who filled out this felt report. So we can actually zoom it out a little and show you fully in Kauai. So there is the blues, and maybe a little green. But you get into the yellows here on Hawaii Island. And so you can see the reports and epicenter with some contours of how much the shaking was, different distances farther out. Another view of that with individual reports. So you can see that it's not just blocks, but there's lots of individual little dots that people are reporting. So you can see those yellows is a more intense shaking. You see it closest to the epicenter here to the southwest. But there's also yellows here in the volcano area, and Hilo and Hamakua. I don't think we can see them right here in Waimea, Waikoloa area, but I think they are there if we look at the previous map, if I go back on this. Right there, oh, maybe not. Keep it going there. So in case you're wondering what this means, here is the scale of the intensity. So this is reported as Roman numerals, from 1 being the lowest and up to over 10 being the highest. Ours is registering in at a 7, more or less, right here in the middle, towards a little bit towards the higher end. But significantly, it's actually short of this very severe shaking. Right. So our category here, most people reporting are coming in this category of intensity of magnitude 6, perhaps right above it. In Pāhala, you might have had some of these 7s as well. Right. But so in case you're wondering what that means, shaking would be strong to very strong. Damage would be light to moderate. Right? I've heard of some light damage, and we had some reports of some minor rock slides. Nothing quite like a landslide, but you can see there are some loose soils on the slopes that got shaken here and there across the island. And in light of our discussion last week about the Helena slump and the research that shows it would take something like 0.4 Gs to actually move that fault, even though that would not be predicted to cause a catastrophic collapse. That intensity of 6 corresponds to peak ground acceleration of 11.5% of a G, right? A 7, that would come in at 21.5% of a G. Up to 8, it doubles to 40, right? So you see it's really in this range of 40%, 0.4 Gs, where you might possibly be getting movement on those faults from this shaking. Not quite enough for that. It was just really right around the middle right here. And then not as intense off towards the coast in the area where we were examining last week. And we'll come back to that again in a little while here this week. Excuse me, USGS released an information statement back on February, let's see, did I miss one here? February 9th, yeah, this is it. February 9th statement about the earthquake, magnitude 5.7 at a depth of 37 kilometers or 23 miles. And the key thing here is that they state it had no apparent impact on either Mauna Loa or Kilauea volcanoes. Right, so that's the most important thing here. They list a bunch of other information, but none of that is super relevant to us right now. They have also, because this was a larger event, added some more products to their page. Right? So, for example, beyond the interactive maps, regional information, the felt reports, they can estimate few economic losses. We're in a green for economic losses, in a green for any fatalities, landslides, all those things, right? They did note aftershock forecast. We have a chance of at least one within the next week. Magnitude 4 was the one that actually registered. We didn't get that. We got magnitude 3s, and was the highest chance here that we saw, 21% chance of those size aftershocks. So all that's falling in line. We have our beach ball moment tensor fault plane solution here. I'll leave that to a different day to explain what that actually means. That's a whole lesson in structural geology here. But they also note here this was a main shock of the sequence of 379 events. And they add this tectonic summary here. And this is what I really want to show you guys, is that we actually have a second description of the event here from USGS mainland office, most likely here. And what they say is it occurred due to oblique reverse faulting. Right? That means something to you if you're a structural geologist, perhaps. But otherwise, it's the rocks getting pushed together and breaking at a high angle and one sliding up over the other one. And it's thought that large earthquakes at this depth are typically caused by a lithospheric flexure due to the weight of the Hawaiian Islands. So that's the same thing as HVO reported. And they note that this event follows the classic main shock aftershock sequence that's typical of non-magmatically induced earthquakes, right? So that's something that's notable. When you have earthquakes that are moving through a pipe and breaking rock like we saw in the Southwest Rift, it's not one big one and then they tail off to nothing. They just keep coming and coming and coming. We saw that last week, right? They just keep coming and coming. So this is not what's happening here. It's not keeping coming. It's just reducing in size and intensity as if it was a regular tectonic event here. They do acknowledge, however, that it did occur near a concentrated zone of long-term elevated seismicity within the mantle under Pāhala. They note it's been particularly active since 2019, with some studies linking it to active magmatic processes related to the deep plumbing of Kīlauea and Maunaloa volcanoes. So that's the key of it there. It's the same thing as I just essentially said, but I like to really cite the information here and show that I'm in agreement with all the other information coming out here as well. So that's the summary there. I thought I could show you one graphic of this, and let's see if we can get this to, nope, that's not what I want to do. If we can get this to load for us, and it looks like some of this stuff didn't save, but I can get it going for you guys here. So this is obviously from the AGU journal, and this is by Klein, 2015. And we've shown this before, but this is a cut through the island and a mantle below it, showing this oceanic crust and lithosphere jointly that's being flexed downwards on either side here, right? Surrounding what's thought to be a broken or thinned middle part of this plate where the magma can punch through towards Mauna Loa mostly. And this is believed to be the case due to the pattern of earthquakes that are seen at depth and shallow, and more beyond what we have shown you guys, like the dots of where they are and when they occurred in what sequence, but more into that beach ball analysis, which they're really looking at the stresses, like which way did the rock actually crack? And if so, what were the ideal force directions that would have pushed the rock in order to cause it to crack? And if so, what's the force field of pressure within the rocks around the island at different depths? And that's the long and short of how they came to an image like this. All right, so our earthquake's down at 37 kilometers. So it's in this range right in here, down in there, right? But it's actually near this magmatic center. So it's somewhere in there. And they're noting that because of that pattern, it's likely within a solid rock rather than affected by some of these roots and actual movement of magma. With a caveat that it has been noted in the past that at slightly shallower depths than this and further over towards Kilauea, there does appear to be an interaction of Kilauea's magmatic roots coming up through that deep part of the crust there. And that causes an extra concentration of flexure earthquakes in that area. That was not what was seen when the study came out. I'd be really curious to see Fred Klein and all the other researchers revisit this with this new data we've had in Pāhala since. But it does appear that is the zone more or less what we're looking at and why it could have been confusing to people. What's clear is that it's way down here regardless. It's not anywhere up here near the surface where it'd be the magma coming towards the surface. So even though I'm sure this causes great concern continually to people in Pāhala and Ka'u, there's still a long way. There's the distance between Hilo and Volcano about, or Nalehu and Volcano, more or less there of depth between where that magma is a solid rock trying to come up. And if anything, this earthquake maybe proved that the rock is actually solid in there and has to break, and there's not a pathway for the magma to come up exactly. So we'll continue to see how that evolves, what the story shows. We'll probably have a lot more that can be said on this after the results of the seismic surveys that occurred under Pāhala are published over the coming months and years here. So that'll be the summary of that 5.7. I did want to show, let's see what's going on with all of my tabs here. All right. Let's force this to reload. And there we go. So what I wanted to show you here, this is earthquakes over just the last single day. And you see that they're happening still around Pāhala in that zone. Those are aftershock sequence likely, and very sparse elsewhere across the volcano. On Kilauea, you see that there is hardly anything in the last day from the summit all the way down the southwest rift. And really it's this further southwest section that's still flaring up a little bit. That was the last to activate and still seems to be the last to slow down as well. Also some events between Kilauea and Maunaloa, this zone that adjusts between them, right? Kilauea has been stretching and moving all over the place down here. And this all supports this flank of Maunaloa. So if it sags, as it recently has, then that might allow Maunaloa to adjust as well. And we'll see that later on. If we pull it back to the last 7 days of all magnitudes, you'll see that there's a lot more that pops up here. And all these yellows are the events over the past week, including that main event aftershock sequence over here. Right? But you might note that pretty interesting lineation right through there. You can see it pretty well. It still shows that over the last week, whoops, sorry, my zoom's not working as I expected here. So there it is. Over the last week, it seems to still have been tracing that pathway down over there, right? And it's an interesting little second pathway right here. You got to wonder if maybe there's a potential of some split and what's going on all through here. We know it's complex in this area. So really, it's all a big question mark of what's going on down in there. What we can see is that there does seem to be that whole effect of magma coming in here still seem to be pushing the land off in this direction a little bit there. So we can look at that a little bit next. But first, let's wrap up that sequence from last week and a half ago. And we'll do that by just showing today's update that the volcano is not erupting, but that seismicity continues at the summit and along the fault system southwest of the summit. Everything is fairly standard in here. I don't need to read all of it. I can just point out that rift zones are still showing low seismicity in both rift zones as well. So pretty quiet overall compared to recent weeks. The USGS has released a video here that shows the sequence of earthquakes, similar to what we showed you guys last week. Their color is a little different, but they're showing that sequence coming from top to bottom down there as well. And this is only going through February 1st. So there it goes. Let's do that one again. Let me zoom it in so you can see a little bit better now as it moves up here. So there it is. They're coloring them by minute, and so they're cycling through the colors, and so that's why it looks that a little bit psychedelic right there. So that was it, February 1st. I didn't pull it all the way down to here because it still took a little longer for the earthquakes to come back down. We do have our own new version of that. I showed you guys Google Earth last week, but to give a shout out to Andre over on Pineapple Zohana with his time-lapse tools, I was able to put this one together as well. This one going further back now from a week before this event, and we're using the USGS map now, right? So there is that first pulse, the second one coming through and all the way down, right, all the way to today, where seismicity decreases, and there's our current map right now. And note, still seismicity down in this patch over here. Let me play it again one more time. You see it's just blue at the start. That'll transition here as we come across. Starts at the top, sweeps down, there it activates. So pretty cool to see that sequence of earthquakes coming across there. And I will note that the USGS did put out an information statement as well on Friday morning before the big earthquake. And this was summing up all the different parameters of this intrusion event that occurred in the Southwest Rift in the days prior, week prior or so. Because they had released the pictures of the cracks and put other information or daily updates, and they hadn't really synthesized it all. So this is a good synthesis of that whole wrapping up the sequence, where they note all different earthquakes and ground cracking, how they changed the alert levels, how the tilt changed, seeing rock falls, all those things. This is fairly extensive, so I'll move past that part pretty quickly. They have a whole section of interpretation and context, right, which they essentially say what we said last week, that magma came into that area, a dike propagated near the surface to cause cracking of the ground surface within a desert, but not shallow enough to actually push its way all the way to the surface. They do note that the connection between the South Caldera, the Kilauea fault system, and the Southwest Rift Zone are not well understood, but the area is dynamic and new pathways can be established between these areas. They're offering a history of the intrusions here, lots of links. Since we've covered all these links before recently, we won't go through them all yet, but they also note what the observatory staff have been doing, continuing to monitor and coordinate. And as usual, they put what can we expect at the bottom here, as usual recently. So the three options they lay out are really unchanged. Option 1, magma continues to accumulate south-southwest of the summit, but eventually stops with no eruption. That to me, seems like the most likely thing at this point in time. It's been a while since this came out already. It's been almost a week. Option 2, magma continues to accumulate in the summit region with an eventual eruption inside the caldera, similar to recent events, right? In which case you'd see a ramp up 1 or 2 hours before. And their option 3, continued accumulation south-southwest of the summit with an eventual eruption outside of the caldera to the south or southwest. In that case, they'd expect to see earthquake locations migrating away from the caldera as observed in December 74 and just a week and a half ago, followed by accelerating rates of ground formation and earthquakes 1 or 2 hours before lava reaches the surface. So that was all seen, right? There was accelerating rates of deformation and earthquakes, but lava did not reach the surface, is what we had happen just this past week and a half ago. So that's the full informational update from the USGS. I thought we could explore this patch down here to the southwest a little bit more. And so I've taken the USGS map and I've made a cross section with A in the northwest and B here in the southeast. I've filtered out all the deep earthquakes because I want to know what's happening with the shallow earthquakes all through here. So one thing to note before I get too far in here is that this is colored by depth. And these maroon colors, these kind of darker reds here, these are marking depths above sea level. So right away, we can see that we have earthquakes marked as above sea level in the ocean. So clearly there's some error there, at least with the depth, maybe some slight error with the location as well, which makes analyzing them a little bit trickier here. But I thought we could offer the context of this region for you to actually see some possibilities, right? And since everyone likes to talk about healing a slump, that's often defined as this area just to the east of this big ridge over here and coming over that way. Right? So that would be the healing a slump area, actually coming on land more, right? Up to there or something like that. This has had a few small earthquakes in there, but not that many. So I think maybe possibly these earthquakes might migrate over maybe to the edge of this thing, maybe. That might be as close as they can get. But it doesn't seem to be activating the interior as of yet. So let me see if I can get this plot to show. Okay, so there's 2 versions of this, as usual. There's time on the bottom and depth, showing that it was about a week ago. There were still events across all depths, so it was still tailing off the main pulse of intrusion. And since then, activity has been more shallow, with a few sparse deep events here and here. Looking at the cross-section itself, with northwest at A and southeast at B. You're seeing here, this is that patch at Pu'uko, that part of the dike that intruded furthest to the southwest. When you look at the map, there's a little gap and then a small patch of events that are shallow. That's these ones over here. And I can pull it back right over here. That's those events right there. The tail end of that dike right through here. So I'm going to pull it back. And off to the side, here are our events, right? So there's 2 clusters, one that's got a little bit more depth range, and then a further one offshore that's got a little bit less right there. Remember, these are maximum 0, really. So everything probably shifts down a little bit in this context. But maybe you're having some movement, and if you were to argue that something is moving over there, it might be these events right through here that are very close to the surface and are in a right position geographically offshore there. But really, it's not much action. It's not really that impressive as we'd expect at this point with this current activity. But there it is for everyone who thinks that the less dramatic version that I tell is boring. I'm really just looking at the data here to see, and if we saw more activation of structures elsewhere offshore, we might be saying different things based on the data, but we don't see that at all. So one last thing on this plot, we can see the rates of earthquakes as well. So there is that pulse of dike intrusion still at the beginning of the month. And then it slows down and you see periodic, like it's really pulsing afterwards, right? There's a pulse, one, and then another pulse, and slow, slow, slow. And then there's another pulse, a small one there, and then slow, 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 and then another pulse. So it seems like it activates in these cycles, like it's still building up, and then it goes and adjusts a bit and building up and goes. which would not be surprising if magma is still injecting into here slowly, right? We're driving a wedge into that area, and even if we're not adding very much volume as much as before, the wedge is still widening slightly more and more and more, and that can cause that transfer of stress forces in that surface block to cause this kind of activity there. So in a cross-section view, I'll recap some of the things we shared last week. There is where those dikes sit within the rift zone area between the fault zones at the summit. Here is that Helena surface right through there, where if we go across there, then that would be what you expect, shallow earthquakes down to maybe up to 4 kilometers depth, somewhere in there. The deeper ones, 8 to 12, that's this lower base as it moves further out, right? Those are the components of our system here. We can show you a little bit more in depth. They actually went by a ship with an echo sounder, and every line on this map here is a place they towed this instrument through the water to image the subsurface of the slope, the offshore slope here. So in the middle of all this, there is Kilauea Summit right there, Southwest Rift, East Rift, Helena Fault Zone. They have it labeled larger here at the top. And right through here, there's a couple of things noted, NP and NR. NP is, I'm going to say I'm sorry in advance here, Rachel and ASL interpreters, but this is a name that just came up. This is Nali'i Kakani, right? And I'll spell it N-A-L-I Okina I K-A-K-A-N-I. Nali'i Kakani, right? So point, Nali'i Kakani Ridge over here. This is Apua Point, and it's the area between these that's thought to be that Helena Basin right through there. This ridge extends further out to a place called, what is it? Palua Seamount, I believe. Right here, I have to look at that name again. And that is kind of the boundary. So I'll scroll it down to this other version of the map here, where they have it annotated, where there is that seamount right there. There is the point right there, and that is very near this edge of where Mauna Loa and Kilauea intersect offshore, right through there, right? And Loihi's right there below, but we're further up from that. So very complicated area going on through here. And what I wanted to share here is when we look at this in a cut section here, what they've done is taken the imagery they got from that echo sounder across various lines and made these geometries that we can see. And there is that seamount, and there is the ridge right up there. And what I hope to show you is that that's the western edge of this entire structure that leads to the east. And what's thought to happen is as this material kind of comes down, or has come down in the past, sliding down in the central flank and in this Helena Basin over here, it actually pushes this material up and to the west like that. So that's what forms the seamount. Is actually not an old volcano. It's a big pile of stuff that's been shoved up and over because of this bowl-like structure of sliding offshore Kilauea right there. It's a slightly different view coming up with the point, and oh, look there, it's actually spelled out. Nali'i Kakani Ridge right there. So that's how it would look in cross-section, and what we can do is, what geologists have done, is from the images of your actually Pa'u Seamount, from the images of the seamount and the areas around it, they've reconstructed a geologic map, which I'll zoom in to just this one right here. And so where they have this dark gray area is that old pile of stuff that since then has been cut by faults, which have sliced off some slivers of it and offset them by 3 kilometers thus far. And so a piece of this thing started off over here. And how can you tell? Well, these little dark gray things are little erosional gullies, like little valleys carved in the side of the seamount. And you see the bottom of them over here, and you see the top of them over here. So these used to match up. And you can see that over a course of time, there's been all that movement across these faults. So this is a major fault system that's separating Kilauea and Maunaloa here. And they've actually done a reconstruction, which is what you have to do if you're drawing these kind of maps, and presuming that there are faults and things are moving, you have to make sure that it all works kinematically and geometrically. If you were to rewind it, can you reassemble the thing, and does it actually work, or your geometries and your movement wrong? This is a good test. So here's a reconstruction, right, of what it looked like before, and the dashed lines are where the faults came through and cut this thing and slice it apart in a time since then. So that is the likely candidate, if it's going to come anywhere near this area to the east of Kilauea, of what is actually activating with earthquakes. Maybe it's some piece of this fault that's slightly more onshore there, or maybe the things will locate further over to be closer to this as well. Hard to tell exactly, and obviously I'm curious about this to be talking about it here. Let's see if I can pull the earthquakes back up there again. There they are. What you can see on this map is that the seamount is clearly to the east of it right here, although we do see a little bit of the point and some activation through here. And we know that there's a little bit of error, right? So that's why this seems a likely location for all of this. So all in all, it doesn't seem like anything is slumping over here, really. Maybe there's some shallower adjustments happening on the Mauna Loa side of that ridge right through here. Right, so I hope that's explanation for how that ties into the whole sequence here. Okay, so that is enough earthquake talk, focusing on just the earthquakes. We can integrate our monitoring signals. So let's do that by looking at the tilt here. Starting off with a week-long tilt. So there's the big drop that offset the instrument last week during a big earthquake, 5.7. And you can't quite tell through the graph here. I'll try to trace it. The tilt had been kind of flat. If anything, not really convincingly going up or down either way. When the earthquake happens, we drop all the way down, and then we immediately start inflating again. And we inflate for several days, really some small little cycles, all the way up until yesterday, when we appear to have begun what looks like it could be the start of a deflation-inflation cycle, but something has changed a little bit. This is the same pattern we were seeing before the intrusion, so I lean towards it's probably a deflation-inflation cycle. We'll have to wait and see, of course, as usual. So there are the earthquake counts, which you can see are fairly steady at around, this is earthquakes per day. So the maximum was about 130, and the low was around 80. And that's in this entire region, including the Pāhala aftershock sequence and Kilauea as well. And so the last week earthquakes over time, there is the deeper ones coming through. There's not really a whole lot of them kind of through here, but not a lot at the surface either. This is more impressive when we look at the month time frame. So there's our 1 week, the entire map area capturing earthquakes. So 723 events in the week in the entire box here, all the different depths. So looking at the last month now, we were zoomed into just over here. So that drop with the earthquake and following inflation, that's right there. And I want to show this so you can see in comparison to the deflation we had last week at the end of the intrusion. That was just massive. We're going up from somewhere around 30 microradians up here to negative 35 or so. So you're looking at 60-ish microradians of deflation here. So even if this thing had kept inflating, it would have a long way to go to reach the same level of pressure that it had 2 weeks ago. And that's the real takeaway of what's happening here. What we're seeing is just small adjustments following it, adjustments to the earthquake, adjustments to the deflation. But all in all, the big story of this month is still how much the summit sagged at the top. Right? That's the summit signal. This is similar to the blue line right through here. So we can see the upper southwest rift connector there, also a huge amount, and had a similar pattern as we talked about in our summary there. At present, they're both deflating here. So maybe you can tell it's going slightly down and slightly down there. So they're both deflating at present. And maybe magma is still feeding further southwest where there's no tilt meter and still causing those further southwest earthquakes that are being observed. Okay, so for the whole last month, depth versus time, we were just looking at this little bit in here, which wasn't as exciting, but now in a context, you can see how it's still more than before this event began, but less than during its peak right through there. You don't really see the big deep Pāhala event, but you do see that there's more blue dots after this point in time when the earthquake occurred. So very slight increase there at depth. So we're not capturing a full cloud of aftershocks on the map there. For the last month, there it is, an asymmetrical peak. So very low to start. Remember, we still had some after effects of the previous intrusion pulse in December and November. This comes up, peaks on the 31st. First and second are also have high counts of earthquakes. And really on the third, it drops off quite a bit, but still at higher levels than we saw prior to the event. So really it's still ongoing and not quite over. And what we saw following October and November, December is that this can go on for a while, right? And really the middle of January was the quietest time of all the last 6 months since October. So this has been more of a normal between these pulses that come in, a slower filling with bigger pulses that accentuate once in a while, almost erupt once in a while, perhaps too. So here's a context of the whole last year, earthquakes per week. So the week before last, we were over 3,000. Last week, we're down under 1,000, and that's more in line with what we're seeing prior. There's September eruption. So there is our October to now Southwest Rift era of injection here. And yeah, that was really a noteworthy separate event that was really significant. And even with all that, it still didn't erupt and still has made more room for the volcano to fill on the inside. Over the last 5 years, earthquakes per month, we actually split between January and February there. So for this to be the peak of January is pretty impressive. February will come up and be pretty tall as well. It's going to continue this pattern that looks like of increased seismicity overall. So that's all the earthquakes integrated with all the other data. We can turn a look at GPS. The USGS has still had their data signals updating irregularly because of their system upgrades, moving away from Wikahuna Station, since that's being now renovated by the park, demolished and renovated. And we do have some updates in the data from GPS across the network here from USGS. So at the summit in Kilauea, what we can see here is this big drop is the drop of the distance north to south as the summit sagged back together as magma left this area to flow in the southwest rift. I showed you guys a massive tilt drop. This is the equivalent on a GPS signal. And that right there. And what's notable is that since then, it has continued to expand, right? So it looks like Hale Ma'u may be refilling still and stretching out as shown by this north to south across the caldera line. Down the rift zone at Pu'o'o, we don't see really a whole lot of change. We see a little bit of variation, but not unlike variation we've seen in the past of this line. And there's nothing really significant happening there that this signal is showing us. We'll show you some effects here when we come to our 2-year GPS signals, and we'll do that in a minute. But first, let's look at tilt elsewhere. Besides the stations I showed you guys, there's a few more. This is the escape road, which is the connection between Upper East Rift Connector and Kilauea Summit. And you can see that when that intrusion event happened, it also showed a little bit of inflation there. So likely as magma pressurized the whole summit, it went not only into the southwest rift, but also into the Kilauea and the upper east rift connector, to show a little signal here. Note that it stabilized afterwards, and earthquake shook it as well, with very little change affecting it thereafter as well. And a little bit of offset there. That's the escape road signal. Over at Pāhala, we see that there was a little bit extra deflation that began a few days after that main pulse of intrusion. That's still kind of curious, and maybe it's related, but not anything definitive. Earthquake shook it a lot, and it's been pretty flat, and if anything, still coming down since then. Like, there certainly was offset where the ground moved and stayed moved. It didn't come back to its original position, right? Likely because there's some crack nearby that was able to accommodate some of that adjustment. So certainly shook the ground a lot over at Pāhala. Further east at the Jonica station, the ground shook a lot too, but no effect on any of the tilt. So really no effect further down the rift for people. There's one more that came back online, Kilauea here. And Kilauea is also paralleling the deflation seen at the summit. So this blue line points a different place than the last blue line pointed. This one's pointing to Hale, showing deflation as well. So all consistent there. So we'll look at 2-year GPS next, and let me switch here to Google Earth so you can have an idea of where these signals actually are. And I thought what we could do is maybe we'll start at the summit and work our way down, right? So furthest to the northwest, this is Wikahuna Station right here. And that's what the 3-component GPS looks like. If you haven't seen this before, these are up and down at the very bottom, north and south in the middle, and east and west at the top. And this is going back for the last 2 years. So what it's telling us, for example, looking at the up signal, this is usually the one to look at the first and is the most important one, right? So it's telling us that over the last 2 years, the summit of Kilauea has been rising, and occasionally it drops a little bit when we have some kind of eruption or outlet of pressure. Rises, eruption, rises, eruption, rises. Didn't erupt, but the same pattern. It dropped down again, and it's actually continuing its rise. It's hard to tell at the very far right here because it's compressed from 2 years, but it does appear from the last graph, looking north and south across caldera, that does seem to be expanding still. So the point being that the relief of pressure, the downward drop here for this intrusion, was just as big, if not bigger, than the last several eruptions in the area, right? So it did a lot of work even without putting lava to the surface, right? What we can see is that this station normally moves to the west and to the northwest. It's in the northwest part of the crater. That makes sense that when a crater fills up within the Hale, it gets pushed northwest. And after it sagged back southeast, it seems to be resuming north and west. So it basically just got shook and deflated, and now it's trying to refill, but it has a long way to go. That is Uekahuna. We look further down here at the outlet station. That's right in that connector area. And it also, go back, push the button there by accident. So outlet station, there it is. And it dropped quite a bit as well here, and seems to have stabilized recently with a cluster of points there at the bottom. Similarly with its north-south, and similarly with its east-west. BC got massively offset here, right? And since then appears to be somewhat stable. That's the important thing. We go further to the east. Let's look at all the way east at Byron's Ledge first. Byron's Ledge, look at the amount of drop over there. Much bigger. This is closer to the Kauai fault zone. This is likely why this is the case. But you see a lot more effect than any of the previous eruptions that we've had here on this plot. One thing that happened prior to the September eruption was an intrusion in this area that caused an offset at Byron's Ledge. So this actually stepped up, right? So it's just showing if it got shoved that far to the north, how much magma was collecting south of that area in the Kauai. Right, and that would make sense that why once that area is draining towards the southwest, that would drain as well. But here the signal is a little different, right? If let me zoom into all the way to that one over here. Here, this signal dropped a lot, but it's still dropping. A slightly slower rate, but still dropping. This has not finished adjusting over here to the east yet, right? And otherwise, kind of similar. But if we come down to crater rim station, it's also going to show us in that middle component that it's been moving. And this is not the up and down, but the north-south. So it's sagging back to the south, right, towards the Kilauea as the area deflates there. So that's the near summit area, right? So what I'm basically saying is refilling in here, and it has been emptying south of these two stations over in here, right? So that seemed to have been relieved. This was relieved initially, now seems to be blocked off where it's filling up and pressurizing once again. And so looking at the effects of this thing, we can come down the southwest ridge, southwest rift here, and look at Ahua, for example, and look at, it certainly got shoved to the west and to the north when this happened, right? And since has dropped down. So there it is, right? Maybe not shoved, but felt like, sagged back to the north and west as this area also deflated, magma draining further and further down and accumulating all the way down in here where there's no tilt meter, unfortunately. What we do have is this station is the Kipukanene station here. And this one you can see was actually shoved upwards by, that looks like 0.8 maybe, and that looks like it could be 0.4. So you're looking at 4 centimeters, 4 to 5 centimeters, a couple of inches. That was actually pushed upwards around and lifted up while it got moved to the south and to the east. And south, it moved, let's see, this is now looking at tenths of meters, right? So that's looking at, call it -15 and down to -40. So we're looking at 25 centimeters. It got shoved south. And what's that? About 10 inches. And to the east, it got shoved. Wow, look at that. It goes from a little under 0.1 to a little under 0.4, 30 centimeters or so. Right, so more like a foot. It got shoved off to the side. So that's a lot for this thing to be shoved off the side. So now you're starting to see where it's accumulating. It's accumulating near this thing and further from this thing. Right, so here's the zone where it's starting to collect, where the dike was intruded, where they saw the cracks in the surface, all that matching up through here. Right, so similar, I don't have to read every single measure of the scale of this coming forward, but Kilauea also got shoved significantly over to the east here. It's like 20 centimeters or so. To the south by, what's that? Like 40 centimeters, 30 centimeters again. Came up a little bit, a couple inches as well, Kilauea. We come all the way down to the coastline. Let me zoom it out so you can see a little bit more where we are. And all the way down here at the coastline at Lemakule, that station got shoved a lot also, right, to the east by several inches, to the south by several inches. It's all the way by the coast, so you don't expect it to really rise. It didn't really rise, but it really got shoved from the side quite a bit. And if I come all the way across, let's go along the coast. Apua Point is offline. Kaena Point, all the way down here, didn't move up, didn't get pushed north or south, but just to the east. But it did move to the east by a couple of centimeters, maybe an inch. All the way over here. It makes sense it wasn't pushed north and south, it got pushed east and west by accumulation. That moved. You can keep going. I can go all the way over. I can go to Kamoamoa. It moved, sagged back to the west when the summit deflated. North Pu'o'o Crater, sagged back to the west. Still dropping, nothing pushing it upwards there, but it's adjusting the pressure further over. Jacuzzi Station, same thing. Sagging back to the west, all the way over here. And finally, if we come all the way to the Jonica Station, all the way here, we see no effect. No effect. But that shows you how far this thing had an impact. In the places we have stations, for sure it affected all of that. A massive adjustment in the volcano here. But critically and reassuringly for anyone in the southeast rift zone, no effect further over than that. So there's a lot going on there. I'll move on from that for now and come back to our GPS. And what I'm going to show you is the 10-year GPS to put it in context once again. So I'm going to just focus on the up and down over 10 years. So this is 2018's summit collapse right there. And so since then, we've resumed quite a lot, regained quite a lot. We didn't quite remake it to the previous elevation height there. But you maybe can see coming in that this drop was pretty big. And in fact, might be the biggest drop since 2018. The biggest outflow of magma from the summit since 2018 was what happened here. And not surprisingly, since it left the summit region and went down the rift. Right, but same thing, Byron's Ledge there. You see it drop off. The crater rim is a little different to adjust there, but here's an outlet station closer to that pipeline, the Southwest Rift Connector. We still, even as much as that ground had swollen by a couple of weeks ago, it still was nowhere near what it had accommodated prior to 2018's collapse. Right, which maybe if you're looking for a reason of why did this thing not actually erupt, it had all this accordion stretches that the thing accordioned closed, and now it's being swollen back up. And when magma starts moving to the surface, it has a chance to push all the way up, and it maybe tried, but the land was able to stretch and accommodate that pressure enough, obviously, if it did not come out of the ground. So that's what I was trying to show last week, and I didn't quite come up with the data offline there, but just the context of how much we are, how the scale compares, right? And this is outlet up by the summit where we had a lot of deflation there, and once again here. If we go further, other places in the south flank, we'll maybe just scan through, right? There's Ahua Station, similar pattern there again. Puhimau, similar pattern. Devil's Throat, similar pattern. Ainaho is offline. The two that have been different have been Makaupuhi and Kalapana Trail. These ones that what's been different is when the eruption was over in 2018, they were showing a refilling of that rift zone area there before turning around in mid-2021. And then since then, the ground has been dropping. But this is a part that's been interesting. The stations have been moving to the north, Makai and Kalapana Trail as well, this one too. And that is what seems to be the area that pinches the rift zone closed. So all this wiggling is trying to adjust the land to allow that to reopen someday. And maybe we're seeing it finally turn around here, but we'll have to wait and see how it all fits together, because what we have shown is that as far as all the way over here, right? So here's this one is Makai, and this one is Kalapana Trail. So these are the ones that are moving to the north right there. And that's what pinches this thing closed. But we know that this event affected all the way to here. So affected the coast all the way down here. So this has a chance to have wiggled these blocks, and we have to see what falls out after all this adjustment. Yeah, so when the USGS reported 20 centimeters of a horizontal offset, there it is right there on the Pāhala station. When they report the 50 centimeters of vertical offset up and down, that's something that could not find on these instruments right here. There are other instruments in the USGS network that are not all shown on here. So for example, this is a USGS map, and you can click on some of these instruments, like this is the Cone Peak instrument. But if you click on there, you'll see like, okay, there's actually no data online from that. So there's this one over here, the KOSM, no data online for it as well. It's hard to pick this stuff out. There is another site that has the KOSM online, but very hard to see how much that is actually dropping there, or how much it rose during the event. But what you can see overall is the same pattern from 2018. That was the intrusion 2021, and then up to where we are now. So all is consistent, and what it really seems like where that vertical offset's coming from is the satellite data. So this is the most recent mounts image, showing the satellite difference over the last couple of weeks here. And this is not news to us, since just last week we saw the USGS release this image, which is much broader, right, than what we just saw, that little section right through there. Rewind it back so you can see it. There it is. And here's our USGS version labeled, for those of us that are not expert readers of these images, showing the ground dropping here and rising centered right in there, with the zone of impact of the actual rise of the ground something like that. It's hard to tell. This area right through here that doesn't show these stripes is all forested, and the satellite can't really pick it up. So it could be at this outer line. Maybe it goes all the way like that, for all we know, right? But somewhere in there is a zone of impact of vertical offset. And from that, we can get 50 centimeters coming up. So I think that's the combination of data streams, satellite and GPS on the ground there. And at this point, I'll jump over to our volcano watch, because it gives us a little bit more information, as well as playing on Valentine's Day this week. So I will just highlight that they are very thankful to collaborate with University of Hawaii and Hilo geology and anthropology departments at the USGS. So among collaborations, just over the past 2 weekends, they have conducted leveling and GPS surveys along the Kauai fault system south of Kilauea. They use essentially that equipment we talked about last week, the 3-meter leveling rod that they call a 10-foot ruler, tape measure, and a sighting scope. And here is the results. This is a little bit of extra data reporting here. Data shows the faults along Kauai were squeezed together by several inches, and the ground was raised by more than a foot, 30 centimeters, in some areas from the intrusion. So they've walked back across there over the last couple weekends, and they found quite a lot of change. Now, one thing I just want to caveat here, if I want to pull back our 2-year plot, for example, let's find a station that's like Ahua down here. That's kind of down in that area right there. And so, as we can see, the second weekend ago, this was still in the middle of adjusting, right? So it could well be that they get a data point somewhere in here in the middle of adjusting, and they can still compare it to a point back in the late fall somewhere in here and see a rise of the ground without capturing the full detail of it rising and falling a little bit between when they measured it and the previous iteration. So still a net gain, but there's a little bit of mess in there because of the timing of this still being ongoing on the volcano there, right? So, so they do note that there was adjustment of the cracks kind of closing. That would be expected if you saw that area sagging and draining to the southwest, and also could be expected if you saw Hale Mau swirling to the north. Either way, and also the ground rising up, showing that injection below that whole area there. So that's cool to see that report. And we also have an image of the way that USGS returns the favor, with technicians here giving instruction to university students on the use of the scanning electron microscope and their fancy new wavelength dispersive spectrometer that's there as well. So they are there helping the students learn, and there have been quite a number of students from that program that have now become geologists at the HVO. So it's also a little bit of a training ground, right, if you would like to go into that field long term. So that's Volcano Watch this week. I just wanted to put that in there because of that extra little bit of information about the Kauai closing up as well. And here is a little bit better resolution your Valentine lava for the year. Lava Valentine. Okay, let me wrap it up here. Volcanic hazard is really not much. There's not a lot of gas coming out. It can affect nearby areas, but everything's been in a green national park all through here. And that's really all we have to say on Kilauea. So we can touch base on Mauna quickly here as well. And note that the earthquake shook it quite a bit as well, but otherwise no noticeable change on this scale of the tilt at all. Not that maybe you can really see it, but you see very few earthquakes at depth. Right? Let's keep going to the 1 month view, or if I zoom it way in here, you can note that this blue line is coming down very slightly, coming down in that pattern. Gets offset by the earthquake, but it continues going down, as you can see maybe right there, by a 1 pixel drop, easiest of all. And maybe more convincing is if we come to this depth versus time. So this time marker right here, on the 9th, corresponds to the same one right there. And you see there's not really any change from before and after the earthquakes. Kind of low-level earthquakes, all pretty shallow, and still same afterwards. So not much change there on Mauna Loa. Earthquake rates are quite low, less than 7 a day, all month. And here it is per week for the whole last year, really showing quite low values of earthquakes compared to the buildup. Right? So really what we are is in the recovery phase of the 2022 eruption of Mauna Loa still. There's the maps for the last month and week, and not really a whole lot of interest there. The last thing that gets interesting to us is the GPS once again. So we have 2 different measures here on Mauna Loa. One is similar to Kilauea. It's the north-south distance across a crater right here, this upper panel right here. And you can see that it was coming up faster, and then it's a little bit slower, and then it's quite a bit slower as far as expanding north to south across that gap right there. We look at the upward component of the up and down, and it's not quite as flat here at the end. It's still rising a bit there, right? This is a little easier to see if I come down to the 5-year. Here's a 5-year horizontal. There is eruption in Mauna Loa, the cracking of the ground, the relief of pressure, and this is all recovery. This little bit gap in this data station right here. But you can see pretty clearly it was coming up faster, and then less fast, and less fast, and here it's essentially flat at the very right end of this 5-year plot. If we look at the upward component, similar pattern, but maybe still going up, right? And if you've caught on to which of these I value more as an indicator of magma, it's the up and down, because it's hard to push something. It's harder to push something up unless you have the faults doing funny angles, and which happens all the time. But normally, what we see is the top of the volcano is getting pushed upwards. It's likely magma pushing it inside in the middle. That's the most likely thing. So it's still refilling with magma as it reinflates following its eruption. And in that case, this little flat bit may be an effect of the southwest rift intrusion on Mauna Loa a little bit there, right? Because it's also swelled in that area. Let's see if I can get the map back here. Where's my closest map? Let's take this one. And so right through here, this piece of Kilauea is pushing Mauna Loa's flank up here on this side right there. Right? So if I come back to our Mauna Loa map, here, Mauna Loa map, right there. Let's take this one, for example, either one of these. Right, that direction is from over here. So that could actually keep this thing not expanding as quickly if you're having extra push from Kilauea for some period of time. How will we be able to tell if that's really what's going on? Well, it's by seeing what happens next, right? If what we see is the southwest rift of Kilauea slow down or stop, and then this thing actually resume back upwards, then that'll be our answer for sure. That's what it was, without the complication that everything is affecting what comes afterwards, right? So having now taken this branch of causality, that could affect how it adjusts in the future too. But we'll see if the signal is strong enough, you can still maybe see it. That's the most interesting thing in Mauna Loa, really, is how is that flank adjusting there? But it seems like it's still coming in slow magma in the middle and nothing unexpected there. So that's it for Mauna Loa. And we'll round it off with our typical community events here. And I do have a special time lapse in case this is where you usually tune out. I'm going to do some bonus time lapse here and end this. But to start off, events at the National Park in February. There are a few in the next week before we're back with you guys next week. And the two upcoming are Art in a Park on Saturday in Kahuku, demonstration from noon to 3, or a talk on Tuesday, also by artist Diana Miller, on her, it looks like her artwork and how it's affected by her past, being born in France, traveling the world, retiring as a lieutenant colonel in the Air Force before becoming a park ranger. Right, so she's also a park ranger. We heard the rangers on Tuesday say that she's also a comedian. She gives great programs, so that would be interesting to check out there as well. And then the following day, next week, Wednesday, there is a Naleo Manu, Heavenly Voices of Hawaiian Music program at the National Park. It's a concert, Hawaiian music concert trio, Chrissy Lassiter and friends. So that also coming up within the next week here, events at the park. Construction closures, we can update you on that in a national park. Everything we said before is scratched off, and we have a new only single closure at Uekahuna right here. So for all month, what they've done now is partial closure of the area, and they've opened 2 bus stalls closest to Critterim Drive for vehicles exceeding 26 feet in length or 8 feet in width. So that is over here in Uekahuna. They do offer a map. There it is. So there is that extra parking right there. And the red is where they're staging construction, right? Because this is an area of impact all through here, right? A lot of that stuff that was in a tower, the webcams that got taken down, some of the webcams got relocated to this tower over here by the water tanks that will survive. And so the last thing I'll share with you guys here is actually a view from there. And we can have a time lapse. I'll start playing it here of all month. And them staging and beginning to work on this facility. And it's going to take a while, so we just have the very start of it here, but pretty quiet, rainy and wet, lots of cracks in the parking lot there. People over here walking to the summit. I've clipped just the daytime views, of course. But yeah, here come some trucks. They're starting to assess what they have to do, where they're going to put all their equipment. Weekend goes by. And just recently here, this past week, here they come back, loading stuff in a truck. You bring up a container, a couple containers, and there it is. That's where we are today. That little, I'm not sure if it's a bobcat looking thing here, helping them move the heavy equipment back and forth. So work is ongoing there, and it's a little inside at a community corner of the park there. And that is it, Dane. I'll pass it to you.
Yeah, I don't know if you noticed, but Carrie's been putting in a long stint here. We appreciate that, Carrie. Rachel had to take off, and so Carrie's been doing it solo. So just want to acknowledge that. Yeah, we do have a couple questions, stuff like that. We have some donations. If you are here though, first I want to encourage you to like, subscribe, and share and all that jazz that everybody talks about. It really does help though, and it goes a long way. If you are so inclined to make a donation, we take those on hvery.org/donate. And Those donations are tax deductible. We are a 501c3 nonprofit. We also take super chats here on YouTube. We did have a couple of those come through. We had Scudget Ed come through, and paying his gambling debts for the over under, just joking around type of thing. We do need to select another over under date. The interesting thing is Noel doesn't even care what day we select. He's already taken the over. Already convinced people.
Yeah, that's given of recent history, that's not a bad move.
Right. We did have a few questions here if you want to do those.
Yeah.
First one, I like this was from Chris. Asked, given that Kilauea has had a pretty major virtual eruption, would it be reasonable to assume that Kilauea is going to take considerable time, 6 months plus, to recharge and erupt again?
Yeah, I think the easiest answer is yes. It's going to have to do a lot of work to recharge, but it all depends how fast the magma is flowing in. So if the magma flowing in hasn't changed in its rate of flow, then you should expect a similar time, right? Maybe not 6 months, but generally months, we can say, right, between eruptions is what we've seen, right? So, and for one that big, maybe it will be 6 months. It could easily be that, right? We've made a lot of space in there. I've showed you guys how much that ground moved. It's the biggest movement of the ground since 2018. So it really made a lot of space down there. And the more that wedge goes to the end of that crack, then it makes all that space uprift as well. So I think it could take a while to recharge. With a very big butt, it all depends how much is coming in. At any pulse, you can have a big blob of your lava lamp come up and disrupt everything, right?
Right.
Or it could also pinch off entirely and shut off for longer as well, right? But neither of those seems as likely as the rate stays more or less the same. Seeing as it stayed more or less the same back through 2018, right? So that's the most likely thing.
Do this one. Nicholas asked, did the island subside a bit after the earthquake, the magnitude 5.7? Was there anything noticeable on the instruments, essentially, after the 5.7, even though it was non-magmatic? I think that's the question.
Yeah, so when I showed you guys tilt meters and we showed something, I mean, it's something like this one, for
those
example.
Offsets right there, yeah.
Where the blue line starts here and it resumes here. It shook all the way up to here and then went back down. And it didn't arrive at the same place. I think it was actually offset. So yeah, it does settle, and it does that not evenly everywhere. It depends a lot on the local, what's going on very locally, every particular area. So in this particular area, what you could say at Pu'o, that the blue line went like so. This is pointing to northeast. That area at north. No, hold on, that's northwest, and this is northeast, right? So the area north of Pu'o seems to have ended up higher than the area south of it in this particular case. And you could do that every different location. You could be like, well, this one didn't have a whole lot of offset, not really a whole lot there. At Uekahuna, right, it ended up lower, right? So that's more like a southwest there, looks like. Yeah, so in that direction, it actually sagged. So that's how it affects it, but very locally everywhere. This is a tilt meter, so it's very sensitive. The GPS signal, when we look at GPS signals, what we're really seeing is the big deflation, and anything further is all lost in this mess right in here. So we don't see it in GPS so clearly right now with the way we have the data available to us right now. So yeah, right. I think the short answer is yes, in small ways and locally.
All right. Well, I think that does it for questions this week, really. Tried to answer some in the chat as well as we went. Next update for us will probably be next Thursday, seeing as we've been talking about how the activity is kind of waning. Thursday is our normal update time, 5 p.m. Hawaii Standard Time, unless something happens. You never know. Thank you, Kathleen, with the $4.99 super chat. Just says thanks. Appreciate that. Right. All right. I think that does it for me.
Okay, thanks, Dane. Thanks, Carrie and Rachel. And Lou in the back end, mahalo for helping us produce here. Pretty amazing how we've grown our crew here from the days of the iPad in front of the generator with a pencil. Right? Pretty cool. Appreciate all of you guys who are watching us, whether you're watching us live or on a replay. And until next week, if nothing happens, which, like we said, it could not, I wouldn't bet on it, to sum it all up here. So until next week, from HVery, this is Dane DuPont. We got Carrie Kaufman up top. I'm Philip Ong. Aloha, everybody.